Everyone, welcome back. This is Miss Lorette. I'm going to be guiding you guys through the follow-up section to 6.5 in this video. So this is section 6.6, and this is all about solving systems of linear inequalities. So we've learned how to solve systems of equations by graphing. In the last section, you also learned how to graph one linear inequality. So if you put the two together, this section's not that hard. You're just graphing two linear inequalities on the same graph, and then the solution is going to be where their shading overlaps. So let's go ahead and start doing some example problems. So if you look at the first inequality, it's in slope-intercept form. So if you learned how to graph something like this in the previous section, this should be hopefully fairly easy. So I'm going to start at my y-intercept at +2. So I'm going to just put a few numbers on my graph here. I'm going to scale these all by ones. I'll do the same thing for the x-axis here. And I'll plot a point at my y-intercept at +2. This is just to get my boundary line started. And then I'm going to use my slope to plot as many points as possible. So this tells me I want a negative slope, so I want my line to fall as I read it left to right. And I'm going to go down 1 and to the right 2. So down 1 and to the right 2. If I connected those points, my line would fall. And I could keep doing this for one more point. And I could reverse the directions. I could go up 1 and left 2, and I'm going to do that as many times as I can just to get a really clear image of that line. And before I connect my points, I want to see what type of line I need. This symbol does not have a bar underneath, so that means I want to use a dashed line. I don't want to connect them with a solid line because there is no bar. And the next thing I need to do is pick a test point to figure out where to shade. The easiest test point, if it's not on the boundary line, is to simply use the origin. 0 is going to be the easiest number to work with. So I'm going to test the point 0, 0. That means in this inequality, I'm going to replace the y and the x with zeros. And remember, that -1/2 is being multiplied with that x value. So I'm going to do times 0. -1/2 times 0 is just going to leave me with 0. 0 plus 2 just gives me 2. So now I want to read this inequality. And remember, if this inequality is true, this half plane that contains that point all gets shaded. If it's not true, then I don't shade this half plane. I shade the other section of my graph, which would be technically above that boundary line. So this says 0 is greater than 2. That's false. 0 is not greater than 2. So I don't shade this half plane. This is the half plane that contained my test point, so I don't want to shade there. I would shade the other half plane. So to the best of my ability, I'm going to shade it like so. All right, so now I'm just going to change color so we can really see what's going on here. This is where it can kind of get a little tricky because you already have something on that graph. So when we go to graph this inequality, you kind of have to imagine that that inequality that I already graphed isn't there. We don't want it messing us up. So I'm going to graph it just the same. I'm going to start at a b value, my y-intercept, down at -3. I'm going to make my slope a fraction so I can clearly see my rise and run. It has a positive slope, so I know that my line should rise when I'm done graphing it. So I'm going to rise 2 and go to the right 1. Notice I'm moving in such a way that if I connected those points, the line would rise. You always want to double check that against the sign of your slope. And again, I'm going to do that as many times as I possibly can to really get a clear image of where this boundary line sits. And you might be thinking, aha, I found the point of intersection. But that's what we do to find a solution to a system of equations. We have a system of inequalities here. We don't want to just find the point of intersection. We want to find the area of the graph where their shading overlaps. Because remember, for an inequality, a linear inequality rather, the solution is the region of the graph that contains all the solutions that would work for that inequality. You have a range of solutions. So first thing I need to do here after I plot my points is figure out what type of line I need. I want a solid line, not a dashed, because this has a bar underneath my symbol. To the best of my ability here, it's a little easier on paper. You guys can use a straight edge. I'm going to try and connect that with a solid line. And now I want to shade, and this is the part that might be a little tricky because you kind of have to ignore the fact that we've got this inequality on our graph that I put in purple. We want to pretend that that's not there. So I'm going to do the same thing. 0, 0 is a valid test point that I can use because it doesn't sit on my boundary line. So I'm just going to use 0, 0 again. I'm going to replace y and x with 0. Remember that x is getting multiplied with that 2. 2 times 0 will give us 0. 0 minus 3 will leave us with a negative 3 on the right. So now I read this inequality to determine if it's true. This says 0 is less than or equal to negative 3. Well, 0 is not less than a negative number. It's actually greater than, and they're certainly not equal. So this is also false, which means that this entire region, if you imagine that kind of to the left of this blue boundary line, this will not contain our solutions because the test point in that half plane did not work. So I want to shade the region of the graph that's kind of to the right of this line. And it's the entire half plane, including this bit right here. So to the best of my ability, I'm going to shade this part of the graph. And your final answer for this system is the region of the graph where the shading overlaps. And oftentimes it's a good idea to just erase the shaded parts where they're not overlapping, because this is not the solution to the system. It's just a solution to one of your inequalities. And remember, a solution to a system of equations is the ordered pair, or ordered pairs in this case, plural, where you would get a true inequality for all the inequalities in that system. So this part here where it's overlapping, I'm just going to go back and shade that nice and dark. And it's a little tricky to do with the active inspire, but I'm going to do my best here to try and erase the part that did not contain my solutions. So I'm going to do my best to just erase all of this. All of this stuff was these were just ordered pairs that were solutions to one of the inequalities, but not the entire system. So we don't want to show that this is on our graph. So our final answer here is just the shaded region. So you might be thinking, how do I write that as a final answer? You don't. Your final answer is actually sitting on the graph. So it's not like a system of equations where you list a specific ordered pairs. You technically have infinitely many ordered pairs in this particular region, because if you kept zooming out of this graph, this shaded region would just get bigger and bigger and bigger. So the graph actually demonstrates your final answer. Okay, let's do another one. Okay, so here we've got x is greater than negative 3 and y is less than or equal to 1. Right off the bat, we've got some vertical and horizontal lines. They're not oblique. X is equal to a number or less than a number or greater than a number. If it's just an x by itself, that is a vertical and up and down boundary line. Y equals a number, or y is less than, or y is greater than a number. If it's just a y by itself and no x, that's going to be horizontal. At this point, we should just have those concepts memorized. So the first thing I'm going to do is graph x is greater than negative 3. So find negative 3 on the x-axis and draw a vertical line through it. Now remember, we don't just want to draw our line straight away. We want to determine, is it a solid or dashed? If I look at this inequality symbol, it does not contain a bar underneath, so I'm going to do a dash line. So here's my vertical line. Now I need to figure out where to shade. So in the previous lesson, you probably learned that you could use a test point Okay, I could use the test point 0, 0 and see if that's true. Or maybe you learned in the previous section that you can kind of look at these as if they're number lines, if you looked at the x-axis as if it's a number line. Because in chapter 3, we learned how to graph something like this on a regular old number line. You would do an open circle and you would shade to the right. Well, similar idea here. Here's technically where my circle, if you will, is located on my graph, and I would shade everything to the right. So I could do it that way. I'll show you how to do it with the test point as well. Let me just go ahead and shade all of this really quick. So if I wanted to use that test point 0, 0, remember, you're not actually inputting a y value into this inequality at all because all we have is an x. So all you care about is substituting 0 for the x. There's our inequality. This says 0 is greater than -3. This is true. So that means that this entire half plane, which contained that ordered pair, would get shaded in. All right, I'm going to change color so we can easily see what's going on here. And let's graph the second one. Y is less than or equal to 1. So you're going to find +1 on the y-axis, because that's the variable in our inequality. And I'm going to draw a solid line, a solid horizontal line. It's got to be solid here because my inequality has a bar underneath. Whoops, let me try that again. That's a little messy. There, that's better. And you could kind of do something similar to what we did for the x inequality. If you were looking at the y values as a number line, the only difference is instead of it being a horizontal number line, it's a vertical number line. But think about what this says. All of the y values that we shade have to be less than or equal to 1. Well, if you think about where all the y values that are less than 1 are located, they're down here. They're below this value. So that's the region of my graph that I would shade. You can almost think of it as a number line, just like the x-axis. But again, if I was to use that same ordered pair 0, 0 and do it using a test point, the only value that I need to substitute for is the y value. So I can ignore this x value, and I just substitute 0 is less than or equal to 1. Well, they're not equal, but 0 is less than 1, so this is still a true inequality. So I would shade this entire half plane that contained that test point, including this bit over here. Okay, again, you kind of have to ignore the fact that the other inequality is there. You would shade everything below that boundary line. And again, your solution is the region where the shading is overlapping for both of them. Well, it's overlapping in this bottom right section here. So I'm just going to make that part of my graph nice and dark, and I'm going to erase the shading everywhere else because those regions don't contain our solutions. So obviously, if you're doing this on paper, it's going to be ideal to use pencil so you can go back and erase. To the best of my ability, I'm going to try to erase all the shading everywhere else that we don't need. None of this is a solution to the system. It's just a solution to one of the inequalities. And there's our final answer, that part of the graph. Let's try another one. Okay, so they're both in slope-intercept form. Hopefully that's nice and easy. So I'm going to graph this first one in blue. It's got a y-intercept at 2. That's where I'm going to start. So I'm going to scale these by 1s. Here's 2 right here. I'm going to plot my starting point. And then I'm going to use this positive slope to plot more points. And I want to move in such a way so that way my line rises left to right to demonstrate that it has a positive slope. I need to rise once, and then I'm going to go to the right twice. Up once, to the right 2 times. I'll reverse both of those directions to plot some more points. Again, plot as many as you can to really get a clear image of where your boundary line sits. And now I need to shade. 0, 0 is a valid test point that I can use because it's not sitting on my boundary line. So I'm going to use 0, 0. I'm going to replace y with 0 and x with 0, and that's getting multiplied with that 1/2. 1/2 times 0 is just 0. 0 plus 2 is 2. Now let's see if this is true or false. If true, I shade everything. Oh, you know what I forgot to do? Before I shade, I got to do my boundary line. So it's going to be a dashed line in this particular case. You guys are probably watching this thinking, where is your line, Miss Lorette? You need a line before we can shade. There we go. Now I can continue shading. I do a dash line here because there is no bar. And now if I look at what my test point yielded, this says 0 is greater than 2, which is not true. This is a false inequality. So this entire section, which contained that test point, I don't want to shade there because it's false. I want to shade everything else. So to the best of my ability, I'm going to shade this little section up here. Okay, let's do the next one. Again, you have to ignore the fact that we already have a graph there, and we'll graph this one the same way. We're going to start at our y-intercept down at -3. So here it is, down at -3. I'm going to use my slope. Again, it's positive, so I want to make sure that I rise. That line rises left to right. I'm going to go up once, to the right 2 times. Do it as many times as I can. Reverse the direction, go the other way. And in this case, I want a solid line because of that bar underneath. All of these points on this line are also solutions to that inequality. And now I need to figure out where to shade. 0, 0 is still a valid test point that I can use because it's not actually sitting on the boundary line. If I replace y with 0 and x with 0, it's going to look like this. If I multiply here, that's going to give me 0, and 0 minus 3 gives me -3. So this says 0 is less than or equal to -3. Neither one of those things are true. So this is also a false inequality. So everything that was above this pink line here, including this part, right? Because again, we're ignoring that that's there. We're pretending that this part is just blank graph. Everything up here would not be the region we shade because this test point was not true. So I want to shade everything below this line, and that's going to be here. Now ask yourself, where is the region where the shading overlaps? And hopefully you can see right off the bat, there is no region where the shading overlaps. So in this particular system, there is no solution. So I'm actually going to go back and erase all of my shading. Because remember, the part that contains the solution is the part of the graph where the shading overlaps. But if there isn't one, this should look like a blank graph. And I'm just going to write as my final answer, there is no solution. If the shading does not end up overlapping, there's no solution. Let's go the other way now. Let's actually write a system of inequalities for a given graph. Again, we did this for single inequalities in the last section. So you're pretty much just doing the same thing here, but instead of doing one inequality, you're just doing 2. So I'm going to start with the solid line here. And slope-intercept form is the best form. So let's start by finding our b value. There it is. And let's find another nice lattice point. Here's a good one. So this gives me my b value. And if I rise and run, that'll give me my slope. So I'm going to have y. I'm going to leave some space because I don't know what kind of inequality symbol to use yet. And my slope for the solid line, it's got to be a negative slope because that solid line is falling. And I go up 2 and left 1. So 2 over 1, or in other words, just 2. And that's going to be multiplied with my x. And then -1 is my b value. So I know when I look at this line that whichever way the inequality faces, it's going to have a bar underneath it because that's a solid line. Now the hard part, figuring out which direction to face my inequality. If you watched my video for the last section, I showed you that an easy way to do it is just put your pencil on the boundary line and then move vertically until you reach the shaded region. If you move up, it's going to be some sort of greater than symbol. Okay, if you had to move up. If you had to move down, it's going to be some sort of less than symbol. So if I put my pencil somewhere on this boundary line near the shaded part, I would have to move up to reach that shaded region. So I want to pick a greater than symbol. And then we rinse and repeat for the other inequality. Here's my b value for that dotted line. And I've already got a nice lattice point for this dotted line right here as well, so I can just use that one. So again, I'm going to start my inequality y, leave some space because I don't know what type of symbol to use yet. My slope has to be positive here because this dotted line, this dashed line is rising. I go up 1, right 1. So my slope is just 1. 1x is the same thing as just x. Of course, you can write the 1 there if you want to. And then it's going to be plus 2 because my b value is at a positive 2. I don't want to put a line under this symbol because this is a dashed line. So the next thing to figure out is what type of symbol do I use? Well, if I put my pencil somewhere on this dashed line, and it's got to be somewhere near the shaded region, I wouldn't want to do it down here. If I put my pencil on this dashed line, I would have to move vertically up to reach that shaded region. So I want a greater than symbol. Voila, there's our system. You're essentially doing the same thing you did in the last section, but instead of doing 1, you're doing 2. Let's do another one. I'm just going to check how many slides I have here. I think this might be the last one. Whoops. Okay, let's do this solid line first. I think that's going to be the easiest one to start with. I have a y-intercept at -2 for that solid line. And I'll pick a nice lattice point to get my slope. There's a good one. So to start my inequality, I'm going to write y, leave some space for my symbol. It's got to be a negative slope because the line's falling. I go down 1, right 1, so it's a -1 or just a negative x. You can write the -1 if you want to. And then my b value is at -2, so I finish this inequality by writing -2. For this line, because it's solid, I know regardless of which way I face my symbol, it's got to have a bar underneath. And if I put my pencil on this solid line, I want to do it somewhere near the shaded part, I would have to move vertically up to reach the shaded region. So I want a greater than symbol. The harder one is going to be this vertical line. Remember, vertical lines just contain an x. And to figure out which number goes in this inequality, find the x-intercept. Or think about what the x value is in all of these points on the boundary line. This is the point 1, 0. This is the point 1, 2. This is the point 1, -2. All of my x values are 1s. So that's the value that I want to use in this inequality. Now I need to figure out which direction do I shade. Well, there's a couple different ways that you can do it. You can look at the x-axis, again, like it's a number line, and my shading is to the right. So if we were looking at a regular old number line, and we were graphing 1, and we had an open circle and we shaded to the right, we would write this as x is greater than 1, because all the values to the right are going to be greater than 1. And you can kind of see that on the x-axis. All of these x values, 2, 3, 4, 5, they're all greater than 1. So I want to choose a greater than symbol without the bar because this is a dashed line. All right, I think there's one more. Yep, one more. Let's do the dashed line first this time. I'm going to start at my y-intercept, which is right up here at +3. And then I'm going to choose a nice lattice point. This one's kind of hard to see. I think there's one right here. Let's use this one. So I'm going to start my inequality with y, leave some space. My slope has to be positive because my line is rising left to right. So I'm going to rise 2 and go to the right 3. So my slope is 2/3 times x. And then my inequality is going to read +3 because my y-intercept is at a +3. No matter which way my symbol's facing, I don't want to put a bar underneath because this is a dashed line. And I can pretty much put my pencil anywhere on this boundary line because the shading is all throughout here. So I'm just going to stick it here. And I would have to move vertically down to reach the shaded region from this boundary line. So I want to use a less than symbol. Let's write an inequality for the solid line. So I'm going to start here at a y-intercept of -3. Here's a nice lattice point that I see right here. So I'm going to start my inequality y, leave some space. And again, my slope's positive because this line is rising. I'm going to go up 2 and to the right 3. So again, it's a +2/3 times x. And then my inequality has a b value, a y-intercept at -3. I do want the bar under my symbol this time because I've got a solid line. And if I put my pencil somewhere on that line, so long as it's near the shaded part, I would have to move vertically up to reach that shaded region. So this has to be a greater than symbol. So you might be thinking, well, these lines are parallel. Doesn't that mean that there's no solution? Not necessarily. We did do a system of inequalities that resulted in no solution, but in this case, there is a solution. So you have to be careful. If you're looking at a system of equations and the lines are parallel, your answer will always be no solution. If you're looking at a system of inequalities, your answer could be no solution, or it could have a solution so long as the shaded region ended up overlapping. So be careful when you're solving systems of inequalities by graphing. Just because the lines are parallel doesn't mean your answer's no solution. All right, so that's my last example. I hope that you found it helpful. Of course, if you have any questions, feel free to reach out to your math teacher, and I will see you guys next time. Bye, guys.